welcome to Math 20 screencasts by Mr. Ahmed. So today we're going to talk about 1.2, so chapter 1.2, grade, angle of elevation, and distance. And we're going to take a look at the examples that your workbook provides you. So first things first, they do a little recap of the Pythagorean theorem. So again, a reminder that the Pythagorean theorem means a squared plus b squared equals c squared. And what that means is that if you were to take the length of this side and then square it, or multiply it by itself, and then that answer, add it to b squared, which is the length of this side multiplied by itself, the sum of those two would give you c squared. Okay, so adding a squared plus b squared gives you c squared. Here they also talk to you about the tangent ratio. Okay, so here they're dealing with the tangent of angle A. So here they're telling you that whatever this angle is, so tangent of this angle is actually equal to the opposite side divided by the adjacent side. Okay, so again, the tangent of this angle right here, which right now is not provided, is equal to opposite side divided by adjacent side. Okay, so here they say for triangle ABC shown above, this triangle right here, tan A, tangent of A, is equal to A over B. So A divided by B. Okay. So in this example here, use the diagram to calculate the following. So the length of the hypotenuse and the measure of angle A. The length of this hypotenuse, this is the hypotenuse. Your hypotenuse is always across from your right angle actually. So it's always opposite your right angle. Okay, so that's the way you can tell. But it's always the longer side too. Okay, so to get the length of this, what you have to do is you got to take a squared plus b squared, and that'll give you c squared, which is this length times itself. Okay, so that's what they do down here. So a squared plus b squared equals c squared. A squared, or yeah, this one is b squared, but you get the drift, right? It's like this side squared plus this side squared equals this side squared. So you get 6.25, so this is after they square it, right? So 6.25 plus 15.21, and that gives you c squared. Now that's 21.46. So to figure out what c is, because we know that this is now, like 21.46 is c squared. So how do you just make it so it's just c? So you do the opposite of squaring. The opposite of squaring is square rooting. So you got to square root 21.46 to get the length of c. So here you get c is about 4.6 centimeters. Okay. Now, to measure the angle, what they do is they say, well, the angle you're trying to figure out is angle A, so that's this one right here. So you've got to use your tangent ratio. Tangent of this angle is equal to opposite over adjacent. And that's exactly what they write down there. Tangent of angle of A is equal to 2.5 over 3.9. Here's tan A. Here's opposite 2.5 over adjacent 3.9. Okay. Now to get a value for the actual angle, here's where you have to use the second tan function on your calculator to get this little -1 up here. So that way, what that means is that you're actually working backwards. Like usually, what happens is that when you go tangent of your angle, you get a value that actually represents the ratio of your opposite side over your adjacent side. Now if you have to work backwards and you've got to figure out the angle itself, that's where on your calculator you're using second function tan. So that's a is equal to second function tan, and then you put opposite over adjacent in the brackets. Some of your calculators will actually want you to do 2.5 divided by 3.9 first, and then whatever that answer is, on your calculator, you then push the second button and then tan, and then that'll actually give you the right answer. Other people's calculators will actually, the calculator will want you to put your second tan in first, and then you put your opposite over adjacent ratio. Okay, so opposite side divided by adjacent side. You get 32.7 degrees. It is absolutely crucial that you do put your calculator in degree mode. Your calculator has to be in degree mode when working with angles, okay? So otherwise you'll get weird, funky values, okay? So that was example 1. Here are the build your skills questions, and these questions you guys will find posted up on School Zone, like so you'll know what you have to work on. Okay. Um, okay, so new skills, working with slope and the tangent ratio. So we're telling you again that the rise over run, that's the slope, so make sure you don't forget that. Okay. And so tangent of x. So here they're saying that the rise, or the slope of this line right here, is the rise over the run, which is x over y, right? So rise over run is x over y. There you go. And it just so happens that the tangent ratio is actually also the opposite over the adjacent side, which again happens to be x over y. So really, tangent of your angle, you would expect that to give you the slope of this line, okay? Because tangent of your angle is equal to opposite over adjacent, so opposite over adjacent, which again is x over y, okay? Let's take a look at example 2. So find the slope of the hypotenuse as a fraction and use it to find the angle of elevation. So here's your hypotenuse. The slope would be, again, the rise over the run, so 6.8 over 42, except they likely will not leave it, there you go, so they won't leave it as a decimal. They decided to multiply by 10, top and bottom. That way you get 68 over 42. Okay, so you multiply by 10 in the numerator, you'll multiply by 10 in the denominator. That way you got rid of those decimals. And then they choose to go ahead and simplify it by dividing the top and the bottom by 2. So 68 divided by 2 is 34. 42 divided by 2 is 21. Okay, so here's your slope, the slope of this line. Okay, and a reminder again that the slope of the line is rise over run, and in this case, if this is your angle, this is your rise, and this is your run, and oh hey, this is the opposite side to this angle, and this is the adjacent side. So rise over run looks like, for this angle, it's going to be opposite over adjacent. So I mean the tangent ratio of this angle is going to be equal to opposite over adjacent. So again, the tangent ratio of this angle would therefore be equal to the slope, right? Because again, it's rise over run. Tangent of this angle is equal to 6.8 over 4.2. Okay, so here's what they do. Tangent of that angle is 6.8 over 4.2. I know it says 34 over 21, but remember that over here we got rid of the decimals, simplified it, and then you've now got the simplified fraction. So tangent of that angle is 34 over 21. When you're trying to work backwards and figure out the angle, that's where you've got to start using the second function on your calculator. So second tan of your slope would give you 58.3 degrees. Okay. So again, a few more of these questions to try out. And then here they're talking to you about grade. So the percent grade is usually, they're talking about the road grade, and that means if you're on a road, it tells you how steep the road is. Okay, and this is always expressed on a little billboard, and it's usually in percent, right? So here's a formula for it. So percent grade of a slope is equal to the rise over the run times 100. Okay, so example 3. What is the slope of the road as a fraction? So if it tells you that Martin is driving his truck on the highway, there's a sign indicating a 7% grade. What this really means is that he goes up, not he, but the slope of the highway or the ramp or whatever he's on is going up by 7 meters for a horizontal distance of 100 meters. So that's what happens. It goes up 7, 100 meters, up 7, 100 meters, up 7, 100 meters. Okay, so then you get like pretty much a slope going up. Okay, so what's the slope of the road as a fraction? That would be just 7 over 100. There you go. Okay, and find the angle of elevation of the road. Well, here, let's take a look at this. Here's your road, right? We just determined that this goes up 7 for every 100, and this is the angle of elevation right here. Okay, so that's what the question is asking. What is this angle? Well, that's where you got to start using your tangent ratio. Tangent of this angle is equal to 7 over 100. Therefore, to go backwards, if you've got to figure out what this angle is, that's where you got to start using second function tan. And that's what they do. Second function tan of your slope, 7 over 100, that gives you your angle, which is 4 degrees. Okay. Got a few more questions to try out, and then we're moving on to example 4 here. The slope of a roof is often referred to as its pitch. A roof with a pitch of 5 to 8 is a roof that rises by 5 and a run of 8. So again, just a lot of it just deals with slope. All of it is slope. Here with roofs, you call it a pitch, but then with up here, when we're talking about those roads, you call it a grade, a road grade. Okay, so but all of it is really the same thing. It's the slope. It's the rise over the run. Okay. Okay, so how wide is the shed in the diagram below? If the pitch of the left side is 3 to 4 and the pitch of the right side is 8 to 9. Now guys, it's really important that you read the question carefully. It asks you for how wide is the shed. That means that what the question is asking is how wide is it from here all the way to here. Okay, so we've got this length right here from here to here being 3.2 meters, and then from here to here being L. So you're going to have to figure out what L is, because once you figure out what L is, in the very end, once you've got this, you add it to 3.2, that gives you the width of the shed, but you've got to figure out L. How do you figure out L? Well, you're going to have to figure out H first. So, you know the pitch is 3 to 4, that means it goes up 3 for every 4 horizontal. Okay, so you got to learn how to read that. If it says pitch is 3 to 4, that means it goes up 3, which is rise, and 4 horizontal, which is run. So that's where you want to set up your proportion. If it goes up by 3 for every 4 horizontal, then what is h, which is the height, when it goes by a run of 3.2 meters? And that's what they do. They do set it up here. So 3 over 4 is your pitch, right? And therefore is your slope. And what is the height of that when it goes 3.2 meters run? So again, a reminder that you've got to take, whenever you go diagonally, you multiply, and then whatever that is, you divide by the remaining value. So 3 times 3.2, whatever that is, divided by 4 to get h. You get h is equal to 2.4 right here. Okay. Once you do have h, once you've got this length, and you also have the pitch of the right side, so you've got this length right here, you've got the pitch of this, well, now it's just a simple matter of setting up the proportion correctly to get what L is. So the pitch of the right side is 8 to 9, which means it goes up 8 for every 9 horizontal. If it goes up 8 for every 9 horizontal, and we know that h is 2.4, then what is L? And sorry, I'm just kind of pointing around with my pointer, but just to give you guys, just kind of visualizing it, 8 over 9 equals h, which we figured out was 2.4, over L. Okay, so that's the proportion they're going to write over here. So 8 over 9 equals h, which we figured out was 2.4 over L. And then again, just cross multiply. 9 times 2.4 divided by 8 to get L, which in this case is 2.7. Once you've figured out L, which is 2.7, you add this length, 2.7 plus 3.2, to get a final answer of 5.9 meters for the width. Okay, so 5.9 meters for the width of the shed. And you've got a few more build your skills questions before you get started on the practice your new skills. So again, just if you're not sure what questions you should be doing, just check the School Zone, where I will have posted the link to this video. And again, once again, with these videos, you'll not only find the questions that you should be working on, but you'll also find the answer key as well, just to make sure that you guys are, just make sure that your work is right. Otherwise, next screencast is going to deal with rate of change. So stay tuned to that.